Good morning friends, I welcome you all for my online learning classes. So from past some classes we have been studying about matrices. Okay, so in previous class we have discussed about properties of matrix addition. We have discussed something about properties of matrix addition. There we have discussed commutative law, we have discussed associative law, we have discussed the existence of additive inverse, we have discussed many concepts, right? So based on that we also have different types of problems also, right? So next topic here is on the same properties. We have properties of scalar multiplication of matrices, right? After addition, what was the operation we applied? That was scalar multiplication. So we need to study the properties of scalar multiplication of matrices also. Okay, so if Aij and Bij are A and B matrices of order m cross n, the condition should be that both the matrices are of same order. So Aij and Bij are two matrices of order m cross n. Both are of the order m cross n. And K and L be two scalars. What is a scalar? Any constant. It is any number, right? So we are assuming K and L are to be the scalars. Then the first property is K of A plus B can be written as K of A plus K of B. Once again I repeat, K of A plus B can be written as K of A plus K of B. And second property is K plus L of A can be written as K of A plus L of A. K plus L of A can be written as K of A plus L of A. Now let us see them one by one how they can be proved. Okay. K of A plus B. What is A? It is Aij. What is B? Bij. So I can write K of A plus B as K of Aij plus Bij. Instead of A and B, I can replace this matrices Aij and Bij. Okay. What is the here addition of two matrices? Aij and Bij are added. So when two matrices are added, we will get a resultant matrix. Sum of two matrices is also a matrix. So I can write Aij plus Bij inside a matrix. So Aij plus Bij is a resultant matrix of A plus B, right? So it is multiplied with K, right? So if any matrix is multiplied with scalar, each and every element of that matrix will get multiplied by the same scalar. Okay, that was the rule what we have seen for scalar multiplication. If any scalar is multiplied to a matrix, then whole matrix, that is the element inside whole matrix, will get multiplied by that scalar. So that is each and every element will get multiplied by that scalar. So now as we have taken K as a scalar and it is multiplied to Aij plus Bij, so each and every element inside Aij and Bij gets multiplied with scalar. Gets multiplied with that scalar K. How do we represent that? Because we don't have any numbers here, we have the general form. How do we represent them? Take K inside the matrix. So I can write this as K into Aij plus Bij. So this whole thing is there inside the matrix. Now what is K of Aij plus Bij? That is K Aij plus K Bij. That is general rule of multiplication. Right? So what is Aij? There is nothing but A. What is Bij? There is nothing but B. This is how it can be proved, or this is how it can be defined. Okay, so this was about first property. Coming to this second one, K plus L of A can be written as K of A plus L of A, right? Here in first case we have taken only one scalar multiplied to sum of two matrices. One scalar multiplied to sum of two matrices. In second case there are two scalars. Sum of two scalars will be multiplied to one matrix, that is A, right? K plus L of Aij. K plus L of A can be written as K plus L of Aij, because A is what? Aij, right? This can be written as K of Aij from previous property plus L of Aij. K of Aij plus L of Aij. What is K of Aij? Aij is nothing but A, and here also it is A, so we get K into A plus L into A. This is how the properties are there for scalar multiplication. Is that point clear? Okay, fine. So we will see some example how the problems will be framed on this property, right? So by solving some examples, the concept will be more clear. Let us take an example. A is equal to 804 minus 236 and B is equal to 2 minus 2 40 minus 5 1. Now the question here is, find matrix X. Find matrix X such that 2A plus 3X is equal to 5B. Right? They have given the matrix A, they have given the matrix B. Then what they have asked, we need to find an unknown matrix X. Need to find an unknown matrix X such that this condition will be satisfied. 2A plus 3X is equal to 5B. Right? Here we know A and B, but we don't know X. That is what we need to find here. Right? So what is given here? 2A plus 3X is equal to 5B. Right? From this, how can I write 3X? By taking 2A on the right side. If I take 2A on the right side, what I will get? 3X is equal to 5B minus 2A. Is that clear? 3X is equal to 5B minus 2A. Now 3X is equal to 5B minus 2A. 5. What is matrix B? That is 2 minus 2, 4, 2 minus 5, 1. So in place of B, substitute matrix B, and in place of A, substitute the matrix A. So what will be my 3X? It will be 5 into matrix B minus 2 into matrix A. Is that clear? It is 5 into matrix B minus 2 into matrix A, because we know A and B. Right? So what is 5 into matrix A? So any scalar multiplied to a matrix. 5 is a number constant, that is scalar. So if it is multiplied to a matrix, what happens? Each and every element inside the matrix gets multiplied by 5. Okay. So what happens here? Each and every element of this matrix, that is 2 minus 2, 4, 2 minus 5, 1, they get multiplied by 5. So what happens to this? 5 into 2, 10. 5 into minus 2, minus 10. 5 into 4, 20. 5 into 2, 10. 5 into minus 5, 25. 5 into 1, 5. This is 5 into A matrix. This is 5 into A matrix. Now, 5 into B matrix. Now we have 2 into A matrix. Keep this minus sign as it is. Don't make any change with this minus sign. Keep this minus sign as it is here. Now multiply this 2 inside. What happens? 2 into 8, 16. 2 into 0, 0. 2 into 4, 8. Right? 2 into minus 2, minus 4. 2 into 3, 6. 2 into 6, 12. Right? If you multiply 2 inside, what you get? 16, 0, 8 minus 4, 6 and 12. Right? So this is 5 into B matrix, and this is 2 into A matrix. Now what we got? We got 2 matrix, and we need to take the difference of them. We need to take the difference. So if you simplify this, what we should get? 10 minus 16. What is 10 minus 16? That is 3x is equal to this difference of this matrix. So 3x will be 10 minus 16 minus 6 minus 10 minus 0 minus 10, 20 minus 8, that is 12, right? Minus 2, 10 minus of minus 4. Observe here we have one minus and we have one more minus here. 10 minus of minus 4. What is 10 minus of minus 4? 10 plus 4. Right? Minus of minus becomes plus. So 10 plus 4. What is 10 plus 4? That is 14. Next, 20 minus 25 minus 6. Minus 25 minus 6 is minus 31. Then 5 minus 12. 5 minus 12 is minus 7. So if you take a difference, you will get this matrix. I hope this thing is clear. Right? So this is 3x matrix. What is this? This matrix is 3x. What we need? X. So what will be x? 1 upon 3 into this matrix. So x can be written as 1 over 3 of this matrix. Right? So once again, as 1 upon 3 is a scalar, it is multiplied to this matrix. So each and every element will get multiplied by 1 upon 3. each and every element inside this matrix will get multiplied by 1 upon 3, or in simple word we can say each and every element gets divided by 3. Each and every element here gets divided by 3. So minus 6 divided by 3, minus 10 by 3, 12 by 3, 14 by 3, minus 31 by 3, minus 7 by 3. Right, sorry, this is minus 31. This is minus 31 by 3 and minus 7 by 3. Right. So what is minus 6 by 3? That is minus 2. What is minus 10 by 3? As it is you keep it, we cannot simplify. 12 by 3 is what? 4. Then 14 by 3 as it is. Minus 31 by 3 as it is, and minus 7 by 3 as it is. Okay. This is how we can apply the property of scalar multiplication and find out the required values. Okay. So pause this video, make a note of this. Okay friends, I hope you have taken down the previous things. We have seen how the property can be worked on, how the property can be made use to find different types of values which are asked in the problem. Right? Let us clarify those things by taking or solving few more examples. Right? So in this case, they have asked us to find x and y. What are this x and y? These are also the matrices. We need to find the matrix x and matrix y such that x plus y is given and x minus y is given. Right? They have given the matrix x plus y and matrix x minus y, and they have asked us to find the value of x plus y, x and y. So when you know x plus y and x minus y, right? So if you add them, right? If you add x plus y and x minus y, what happens? Y and y cancels. What remains is 2x. So with the help of that, you can calculate the value of x. So x plus y plus x minus y. X plus y is 5209. X minus y is 360 minus 1. Right? So now, as we know, x and x, that is 2x, y and y will get cancelled. 2x will be equal to sum of this matrix. What is sum of this matrix? 5 plus 3 is 8. 2 plus 6 is 8. 0 and 0, it is 0. 9 minus 1 is 8. So we got 2x as 8, 8, 0 and 8. What will be x? 2 taken on the other side. 1 upon 2, 8, 0, 0, 8. So 1 upon 2 is a scalar. When taken inside, it gets multiplied to each and every element. 1 upon 2 will get multiplied to each and every element here. Or each and every element gets divided by 2. Each and every element will get divided by 2. So x will be equal to 8 by 2, 8 by 2, 0 and 8 by 2. What is 8 by 2? 4. So x will be equal to 4, 4, 0 and 4. Now we know the value of x. We need to find the value of y. We can find the value of y in two ways. One is as we have done here, x plus y plus x minus y. When we have done this one, what got cancelled? Y got cancelled and x was remaining. Right? But if we do x plus y minus of x minus y, if we do x plus y instead of plus, if we take minus here, then what happens? X will cancel and y will remain. You will get 2y. Then you need to take the difference of this. Right? X plus y minus x minus y. Then 2y will be there, which is difference of these two matrices. And then as usual you can calculate the value of y. Or as we know the value of x, substituting in any of the equation, either first or second. So I made use of first one. X plus y is what? 5209. So y will be what? 5209 minus x. Y will be what? This particular matrix minus x. Right? 5209 minus what is x? 4004. So now what will be y? Difference of these two matrices. 5 minus 4 is 1. 2 minus 4 is minus 2. 0, 0 is 0. 9 minus 4 is 5. This is how we can find the matrix. Right? You can follow this method or this one. In any method you will get the same answer. Okay? Fine. So now we need to find the value of x and y. Right? We need to find the value of x and y. Here what are x and y? Right? So we can take this capital X and capital Y. Right? What are x and y? They are numbers inside the matrices. Here observe, x and y are matrices. Here what are x and y? They are the elements inside the matrices. Okay? They are elements or numbers inside the matrices. Right? This equation is given. We need to find the value of x and y. So given equation is what? Write down this given equation as it is. This is the given equation. Now we need to simplify this equation to get the value of x and y. Now this particular matrix is multiplied by 2. So 2 is a scalar multiplied to matrix. What is the rule? Each and every element inside this matrix will get multiplied by 2. So I can write this one as 2x, and 2 into 5 is 10, 2 into 7 is 14, and 2 into y minus 3. Plus 3 minus 4, 1, 2. That is equal to 7, 6, 15, 4. Okay, 7, 6, 15, 4. This can be written as 2x, 10, 14, then 2y minus 6 plus 3 minus 4, 1, 2, that will be equal to what? RHS is as it is 7, 6, 15 and 4. Right? Seven, 6, 15 and 4. Now add these two matrices. So what you will get? 2x plus 3. Then 10 minus 4 is 6. 14 plus 1 is 15. Then 2y minus 6 plus 2. You will get 2y minus 4. 2y minus 6 plus 2. Minus 6 plus 2 will be minus 4, and 2y as it is equal to 7, 6, 15, 4. 7, 6, 15 and 4. Now both the matrices are equal, so corresponding value will be equal. So I can write 2x plus 3 is equal to 7. Right? 2x plus 3 is equal to what? 7. 2x will be equal to 7 minus 3 is 4. X will be equal to 2. Is that clear? So 3 shifted on the other side. 7 minus 3, that will be 4. 2x is equal to 4, so x is equal to 2. Okay. Then 6 is equal to 6, 15 is equal to 15, don't need to equate that. 2y minus 4 is equal to 4. 2y minus 4 is equal to 4. What happens? 2y is equal to minus 4 shifted on the other side. It becomes what? Plus 4. So 2y plus 4 is equal to 8. So what will be y? Y will be equal to 8 divided by 2, that is 4. 8 divided by 2, that is 4. This is how we need to find the value of x and y. So please be careful. Sometimes x and y means the matrices. Sometimes x and y means the value inside the matrices. right? It need not be only x and y, it can be a, b, c, it can be p, q, r, l, m, n, anything, right? So be careful, right? Here x plus y and x minus y, x and y are matrices. Here what are x and y? They are elements. How to identify? If they are there outside the matrix, here you can see x and y are independent of this matrices, so it can be considered as matrices. But x and y are inside the matrices here. X and y are inside the matrices, so definitely they are the elements. If x and y are outside the matrices, then they can be considered as separate matrix. But x and y are inside the matrices, so they are elements of the matrix. Okay. So you pause the video as it is and take down the notes. Okay friends, we have taken down the previous slide, so I hope everything is clear, right? So let us proceed with next content, that is properties of multiplication of matrices. Okay, so till now we have seen properties of addition of matrices, then properties of scalar multiplication of a matrix, but now we need to know the things about properties of multiplication of matrices. We should understand what are the properties of multiplication of different matrices. Already we have seen how to multiply two matrices. Now if I multiply two matrices, what will be their property, that I am going to explain here, right? So first one is associative law. Okay, first one is associative law. In addition, in property, when we studied about properties of addition, we have also studied commutative law. What was that? A plus b is equal to b plus a. But here commutative law is not applicable for multiplication of matrices. That is, a into b is not equal to b into a. That we have already studied, right? We have solved problems when we were solving multiplication of matrices. We came across the thing where a into b was not equal to b into a, right? So that is the reason why commutative law is not applicable for multiplication of matrices. Okay, so now first one is associative law. What is associative law? For any three matrices of same order or of applicable order, any three matrices A, B, C, right? A into B into C is equal to A into B into C. That is, AB into C is equal to A into BC. This is what? Associative law. Okay, where both sides of equality are defined. What do you mean by both sides of equality are defined? We never came across this sentence when we were studying about properties of addition, but here we are seeing this sentence. What do you mean by both sides of equality are defined? When we were studying about properties of matrices, that is addition of matrices, what was the definition? Right? In definition you can find of same matrix M cross N. Let A, B and C be the matrices of or same order M cross N. Right? But here it need not to be only same order, because it is multiplication of matrices. Right? What is the rule for order of the matrices for multiplication? Number of columns of first matrix should be equal to number of row of second matrix. Number of column of first matrix should be equal to number of row of second matrix. That is the meaning of this sentence. Both sides of equality are defined. That means here also the matrices should be defined in such a way that they should be eligible for multiplication. They should be eligible for multiplication. Right? And here also the matrices should be defined in such a way that they are helpful for multiplication. They follow the rules of multiplication. Right? That is the meaning of this, with both sides of equality are defined. If it is not well defined, if the order is not suitable for multiplication, then there is no need to talk about this law. Right? If we want to speak about associative law, then the matrices should be such a way that we should be capable of multiplying them. Then only we can speak about associative law. That is the meaning of this. Both sides of equality are defined. Right? A into B, AB into C is equal to A into BC. You can consider any matrix A, B and C. Right? And check, it will definitely get satisfied. When we are solving problems, definitely we will prove these laws independently. Right? Second one is distributive law. What is distributive law? So once again same thing, three matrices A and B. In these two properties we come across A into B plus C is equal to AB plus AC. A into B plus C is equal to AB plus AC, and A plus B into C is equal to AC plus BC. A plus B into C is equal to AC plus BC. And once again both sides of equality should be well defined. Once again both sides of equality should be well defined. Right? So once again same meaning here. Here both sides of equality should be defined in the sense the ordering should be in such a way that they should be eligible for matrix multiplication. Fine. So these were the two properties, associative law and distributive law. Now coming to third one, existence of multiplicative identity. Right? Existence of multiplicative identity. When we were speaking about additive identity, what was the rule? If you add any matrix to matrix A, you should get matrix A itself. Right? You should get matrix A itself. That time what was then the matrix which is added, we call it as what? Additive identity. Right? We call it as what? Additive identity. What was the matrix which was used as additive identity there? That was zero matrix. That was what? Zero matrix in case of addition of matrices. And when I was explaining that, right, so I have made it very clear that identity matrix is different for addition and different for multiplication. And I have also given a statement that both were different, and for multiplicative, right, the identity matrix for multiplication is unit matrix. Right? Unit matrix. If you want, you can go back to that video where I was explaining about additive identity. You can find that thing. I have clearly mentioned that the matrix for identity matrix for addition of matrices is different and multiplication of matrices is different. And at the same time, I also cleared it. For addition, it is a zero matrix, and for multiplication, it is unit matrix. Identity matrix for addition is zero matrix, and identity matrix for multiplication is unit matrix. And what is unit matrix? You can refer my first video on this matrices. So you will find different types of videos. First or second video, you will find different types of matrices explained very clearly. Okay. So now existence of multiplicative identity. So it means that when that identity matrix is multiplied to matrix A, you should get the original matrix, that is a matrix A itself. Right? So let us check. Let A is equal to 3, 2, 4, 1 and I be unit matrix 1, 0, 0, 1. Okay. And here also the order should be in such a way that they should be capable of multiplying. Right? And we know that a unit matrix is also always a square matrix. So our matrix A should be defined in such a way that it is capable of multiplying with I. Right? So let us consider true cross 2 matrix A and I. What will be A into I? That is 3, 2, 4, 1 into this unit matrix. Okay. So when I multiply this, 3 into 1 plus 2 into 0. That is, row should be multiplied to column. 3 into 1 plus 2 into 0. 3 into 0 plus 2 into 1. Then 4 into 1 plus 1 into 0. 4 into 1 plus 1 into 0. Then 4 into 0 plus 1 into 1. 4 into 0 plus 1 into 1. Right? Now what will be this value? 3 into 1 is 3. 2 into 0 is 0. 3 into 0 is 0. 2 into 1 is 1. Sorry, 2. Then 4 into 1 is 4. 1 into 0 is 0. Then 4 into 0 is 0 and 1 into 1 is 1. So what we are left with? 3 plus 0, 0 plus 2, 4 plus 0 and 0 plus 1. What is 3 plus 0? 3. What is 0 plus 2? 2. 4 plus 0 is 4 and 0 plus 1 is 1. So what is the final matrix we got by multiplying A and I? That is 3, 2, 4, 1. Is it not equal to matrix A? Definitely it is equal to matrix A. So this will be equal to matrix A. That was on the left hand side. We'll check second portion of this, I into A. Right? I is 1, 0, 0, 1. A is 3, 2, 4, 1. If I multiply 1 into 3 plus 0 into 4, 1 into 2 plus 0 into 1, then 0 into 3 plus 1 into 4, then 0 into 2 plus 1 into 1. So what I will get? 1 into 3 is 3. So I will get 3 plus 0. From this 2 plus 0. From this 0 plus 4. And from this 0 plus 1. So if I add that, what I will get? 3, 2, 4, 1, and once again it is equal to A, right? So you can see by taking the unit matrix as I matrix, right, this property will be satisfied. Is that clear? This property is going to satisfy. So identity matrix for multiplication is unit matrix, and make it very much clear, identity matrix for addition is zero matrix. There, when we are speaking about additive identity, the order of both the matrix should be same. Here the order should be well defined on both sides. Is that clear? Okay. So I hope all the things are clear. Today we have studied about properties of scalar multiplication of a matrix, properties of multiplication of matrices, and we have also seen a few examples on scalar multiplication of matrices, right? And we have studied different properties, existence, distributive law and associative law in multiplication of matrices. So today we are going to stop this video here, right? So you go through the video very carefully, and if you get any doubt, you can comment me in the comment box. In the upcoming videos, next part of this video, we'll take some examples and prove associative law, distributive law, okay? And we'll continue with the different types of matrices, how to solve them, everything will continue in the next class, okay? So we'll stop here. Take care, go through the video carefully and make the notes properly, okay? If you get any doubt, you can comment me back. Thank you.